Okay, so today we're going to take the next step. We've dealt with all those operations with numbers. Now we're going to take a look at operations with integers. And integers include the whole numbers that we've been working with, but they also include then the negatives. To deal with integers, we need to step back a little bit and look at how we actually combine numbers, whole numbers with our operations. And what we're looking at is we're going to be looking at the counts of the numbers, not the names. So we're just going to be dealing with that amount, the count of the number for today. And the first thing we need to be able to do is we need to be able to represent an amount. If I give you the numeral 6, to represent that, we use a number line. Pretend these are evenly spaced. Now, there are a couple of different ways to represent a 6 on the number line. One of them would be to just put a dot at 6, which, if all I'm looking to do is represent that value or that amount, that works just fine. But if I'm looking to do anything with it, that's not a very usable or mechanical definition. So a more usable working definition is a vector. Now that word vector is just a fancy word for a simple thing. As you can see, it's just an arrow that starts at 0 and goes to 6. I got a little touch along there, but you guys get the point. For addition, if I want to do 6 plus 3, addition means combining vectors. Physically put the vectors together. So I have the 6. If I have a 3 here, to put them together, I'm going to take the vector for the 3, and I'll move it over and put it with the 6. And you can see when I put those two vectors together, they end up at 9. 6 plus 3 is 9. Hopefully we all knew that before we started today. But it's that definition that allows us now to look at integers, negative numbers. I'm going to draw a new number line down here. So if I have a problem like 6 plus a negative 3 now. Now in a couple of classes, we're going to talk about order of operations. And parentheses are one of, bless you, one of what we call an enclosing symbol. In this case, that parenthesis is not really an enclosing symbol. It's not telling us to do anything first. It's just telling us that is a negative 3, not minus 3. So a lot of times when we're working with negatives, parentheses get used to just kind of isolate the negative number. So 6 plus negative 3. So a 6, the vector starts at 0, goes to 6. The negative 3 is a vector that starts at 0 and goes to the negative 3. Now you can see that vector has the same length. The length is what we call the magnitude. Has the same length as the vector that would be positive 3, it just goes the opposite direction. So to add those together, we're going to do the same thing. We're going to take that vector, oops, I'm going to drag it over here and put it with the vector for 6. And you can see we end up at 3. 6 plus a negative 3 is 3. Now, I don't expect you to draw out a number line every time we add integers, but I do keep that image in my head as I am working with integers. For example, I might have a negative 17 plus 9. What I am picturing in my head is here's 0. Negative 17 goes in the negative direction. Positive 9, since it's positive, it goes in the opposite direction. Is the length of the 9 shorter or longer than the 17? shorter. So what that picture tells me, first of all, I ended up on the negative side over here. So I know my answer is a negative number. Second, since my arrows for my vectors go in opposite directions, the magnitude of my answer is the difference in the magnitudes of the numbers. So what's the difference between 17 and 9? 8. So that result is a negative 8. I might have 12 plus a negative 17. So now from 0, I have the 12 verse. That goes in the positive direction. Negative 17, does it go in the same direction or the opposite direction? Opposite. Shorter or longer? Longer. So it's going to go past 0. So this picture is also telling me that we're on the negative side of 0. So our answer is negative. Once again, the arrows for the vectors go in opposite directions. So we know that the values work against each other. It's the difference between their values. What's the difference between 12 and 17? 5. Of course, if you didn't know that, it would be 17 minus 12. The bigger magnitude minus the smaller magnitude, right? Gives us the 5. That result is a negative 5. We have a negative 19 plus a negative 24. From 0, negative 19 goes in the negative direction. Negative 24, same direction or opposite? Same. Slightly longer. So that picture tells us that we definitely end up on the negative side of 0. Our answer is definitely negative here. Do the arrows for the vectors go in the same direction or the opposite direction? Both go in the same direction, which means the values build, the magnitudes build on each other. So 19 combined with 24 is 43. 19 plus 24 is 43. When the arrows for the vectors go in the same direction, you add the magnitudes. When the arrows for the vectors go in different directions, you have to subtract the magnitudes. So in your notes, I want you each to try a couple here right now. I am going to have 13 plus a negative 25 and negative 7 plus 32. Try those two in your notes. We're going to go over them here in just a few seconds. First one, we got positive 13, negative 25, same direction or opposite direction? Opposite. Shorter or longer? Longer. So we're going to end up with an answer. Negative 12. Wonderful. Negative 7 plus 32. Negative 7 goes negative 32. Same or opposite? Opposite. Shorter or longer? Longer. So we end up with positive 25. Or just 25 is fine. Subtraction is where things get ugly. If I give you a problem like 8 minus 3, of course, we all know that the answer to that is 5. That's good enough for now. If I asked you, though, to give me a diagram on the number line for 8 minus 3, most of us would draw something like this. There's 8 minus 3 goes back to 5 like that. If you look at this, though, that picture looks an awful lot like 8 plus a negative 3. Because, in fact, it is the picture for 8 plus a negative 3. Now this would be -3. If I move it to here, that's a -3 there. The reason is these two problems, 8 minus 3 and 8 plus the -3, are the same problem. We've talked a little bit about how addition and subtraction are really the same operation. And we even looked a little bit at subtraction being treated as, the reverse of addition. Let's take a look at what the technical definition of the subtraction symbol is. Now, one thing that we should make clear is an operation, addition, subtraction, multiplying, or dividing, always operates on the number that comes after it. So the subtraction is operating on the 3 here, the number that comes after the symbol. So it doesn't do anything to the 8, it's telling us what to do with the 3. Well, the subtraction symbol means add the opposite. So we add, and then the opposite of 3 is -3. Something like 8 minus 3, since those are both positive numbers, I would just do 8 minus 3. We know how to subtract positive numbers. But when one of them, or one or both of them, is negative, it's usually easier to put it into addition like that. For example, if I have a -17 minus 19, doing it like that, just as it's written, would be tricky for most people. But we can change that. And remember, the operation, the subtraction, operates on the number that comes after it. So the -17 here doesn't change. Subtracting 19 becomes what? Adding -19. And once it's written like that, we can go back to our vectors. If here's 0, it's -17 and -19, which tells us our answer has to be a -36. Perfect. Once we've changed it to addition, we can go back to that little vector diagram and figure out how to combine the numbers. We might have -32 minus 7. What's that going to turn into? Perfect. -32 plus -7. There's -32, -7. Obviously, on the negative side, they go in the same direction. So we combine them, we add them together. 32 and 7 make 39. So it's -39. The one that's usually a little difficult for people to understand is when the second number is negative. Like this, 17 minus a -8. The 17 doesn't change. The subtraction is going to turn into addition of the opposite. What's the opposite of -8? Positive 8, or just 8. Well, 17 plus 8, we don't even have to draw the vector diagram. That's going to be 17 plus 8 is 25. The negatives are all disappeared now. Or we might have -32 minus a -23. What does that problem become? -32 plus 23. Change the subtraction to addition, and then the opposite of -23 would be +23. So now we've got -32, +23, same direction or opposite? Opposite. Longer or shorter? Shorter. So it ends up, stays on the negative side, so our answer is negative. Arrows are in opposite directions, so it's the difference between 32 and 23, which is 9. So it's -9. I'm going to have you guys try a couple in your notes. I'm going to have you do -27 minus 12, -32 minus a -48, and negative, a positive 19 minus a negative 23. Have you tried those three and we'll go. Okay, so for the first one here, negative 27 minus 12 becomes negative 27 plus negative 12. Ends up giving us an answer of negative 39. Good. Negative 32 minus negative 48 becomes negative 32 plus 48, which ends up being positive 16. 19 minus the negative 23 ends up becoming 19 plus 23, which is 42. Anybody have any questions on any of those? Okay. Multiplication. We have talked about multiplication a little bit as its basic definition. You know, 5 times 3 is 5 plus 5 plus 5. It's repeated addition. And if we think about it in that way, if I do negative 5 times 3, well, that makes perfect sense. I'm going to take that negative 5 and I'm going to repeat it 3 times. I'm going to add 3 of them together. So negative 5 plus negative 5 plus negative 5, which is negative 15. 5 times a negative 3 is a little bit harder to deal with. I can't take 5 and repeat it negative 3 times, can I? So what I have to do, one of our properties of numbers is that for addition and multiplication, if you think about it, addition and multiplication are the forward version of each operation. Does that make sense? The subtraction is going backwards and division is going backwards. In addition and multiplication, in the forward versions of the operations, they're what we call, and you don't necessarily need to know this word, but you need to know that it's applicable. They're called commutative. What that means is you can change the order. So for this one here, 5 times a negative 3 can be changed to a negative 3 times 5. You change the order, and the result is going to stay the same. So now when I've changed the order, that means I'm going to take negative 3 and repeat it 5 times. So negative 3 plus negative 3 plus negative 3 plus negative 3 plus negative 3, which is negative 15. The one that's a little bit trickier to define is if I have negative 5 times a negative 3. I cannot take a negative 5 and repeat it negative 3 times. But even if I switch the order, if I did negative 3 times a negative 5, I can't take negative 3 and repeat it negative 5 times either. My basic definition of multiplication here breaks down. It doesn't work. Now, we've always been told that that has to equal what? Positive 15. We've been taught a negative times a negative equals a positive. And if you asked why, you've always been told that it just does, right? Well, I'm going to show you the reason why right now. And it's not necessarily a satisfying reason, but it is the reason. The basic definition, as we said, of multiplication doesn't apply here. It breaks down. It doesn't work. This actually happens in math quite a bit, where we hit a spot where the basic definition doesn't work for a particular problem. So what we do is we look for a pattern, and then we just assume that pattern continues, and we define the results of those problems to be what fits that pattern. The same, that absolutely applies to multiplying two negatives like this. If I have negative 5 Well, I'm going to keep the negative 5. I'm going to keep using the negative 5, but now I'm going to reduce this to 2. What is negative 5 times 2? Not everybody at once. Negative 10. There we go. If I keep going, negative 5 times 1, negative 5. So now let's look at the pattern I'm establishing here. We're starting with negative 5 each time. The number I am multiplying by, I'm reducing by 1. 3 minus 1 is 2. 2 minus 1 is 1, right? What is happening to my result? Yeah, it's getting larger by 5. I went from negative 15 up to negative 10. Then I went from negative 10 up to negative 5. I went up by 5. Let's see if that pattern continues. So I'm going to still start with the negative 5 here. If I'm decreasing by 1, what has to go here? 0. 1 minus 1 is 0. Negative 5 times 0 is 0. Did that increase by 5 here? Yes, it did. So my pattern holds. The pattern works. So now we're going to assume that pattern continues. Negative 5 times a negative 1. I decreased the 0 by 1. 0 minus 1 is negative 1. This has to go up by 5. So that would be positive 5. Negative 5 times negative 2. Again, I reduced this by 1 here. This has to go up by 5. So 5 plus 5 would be 10. Go down to a negative 3 here. We have to go up by 5. That would be 15. So we confirm that negative 5 times a negative 3 is a positive 15. The reason is because it continues the pattern. So when we multiply two negatives, we do get a positive. But like I said, the reason we get a positive is kind of unsatisfying. It's because it fits the pattern. So if I have something like 7 times a negative 8, first of all, is my result going to be positive or negative? And negative. A positive times a negative, we saw it's going to end up being a negative result. What is 7 times 8? 56. So 7 times negative 8 is a negative 56. Negative 9 times a negative 5. Positive or negative? Positive. As we saw, anytime a negative is multiplied by another negative, the result does have to be positive. What is 9 times 5? 45. So that is a positive 45 or just 45. A negative 6 times 11. First of all, is the result positive or negative? Negative. Again, we saw that anytime there's a negative times a positive, the result will be negative. 6 times 11? 66. A negative 66. So the pattern that develops here is when we're multiplying two things that are the same sign. A negative times a negative, and of course, obviously a positive times a positive. The result is positive. If we're multiplying one positive and one negative, the result will always be negative. Division. Well, we talked about division being repeated subtraction. I'm going to talk about another definition of division here right now. When we are asked a problem like 12 divided by 2, what it is asking us to do is to reverse the multiplication of blank times 2 equals 12. 6. You got it. So 12 divided by 2 does equal 6. And the reason is because 6 times 2 equals 12. Without multiplication, we cannot define division. If I had 27 divided by 9, again, that is asking me what times 9 equals 27. What would go in there? That 3 times 9 is 27. Therefore, 27 divided by 9 is 3. Now, that seems like a little bit of a tedious definition for positive numbers, but if we throw in some negatives, it makes sense. We have a negative 32 divided by 4. What it's asking us is what number times 4 is a negative 32? Well, first thing I'm going to do is look at my sign. Does this here number need to be positive or negative? It has to be negative because this result here is a negative 32. If the 4 is positive, to multiply and get a negative result, I have to have one positive and one negative. So the 4 is already positive. This number has to be negative. What number times 4 is 32? 8. So it's a negative 8. So negative 32 divided by 4 is a negative 8. $35 divided by negative 7 equals blank is asking what number times negative 7 equals 35. Well, we know that what number times 7 would be 35. It'd be 5, right? Well, let's look at the signs. This result is positive. 35 is positive. To become positive, there's only two possibilities. Both of the numbers I multiplied could be positive. Is that, bless you, is that possible here? No, because I already got a negative 7. So the other possibility is that both of the numbers being multiplied must be negative. So that has to be a negative 5. So this result here is a negative 5. I might have a negative 24 divided by a negative 8. So again, that is asking me what number times negative 8 equals a negative 24. Well, let's look at the signs first. The result is negative here. So when the result is negative, that means I multiplied a positive number and a negative number. The number I already have is negative, so I need a positive. What times 8 is 24? 3. So positive 3 times negative 8 makes negative 24. So you can see the pattern is the same as with multiplication. If I have one negative and one positive, no matter what order they're in, the result is negative. If I have both the same sign, so both negative or obviously both positive, the result would have to be positive. So there are a lot of consequences of these. I'm going to show you just, I gotta be careful what I show you. Let's just look at this. What does that symbol mean? Square. We will talk about this more in the weeks to come. How would I calculate 5 squared? 5 times 5, which would be 25. Good. Now, we mentioned that our operations come in pairs. You know, addition was the main operation. Its inverse, or it can be reversed by subtraction. Multiplication was a main operation. It could be reversed by division, right? Division is its inverse. This is called a power. It's part of exponents. Its inverse is a root. If I want to go from that 25 back to the 5, I do a square root. The square root of 25 is 5. Now that we have the negatives in the picture though, negative 5 squared should be negative 5 times negative 5. What should that be? That's also 25. If I square root 25, do I get back to a negative 5? Well, we just square rooted 25 here and we got a positive 5, didn't we? Because the square root has to be an inverse of a power of 2, the square root will always have two answers. The square root of 25 can be positive 5 or negative 5. Both answers apply. Now, when we're dealing with a real life application, most of the time, the number we're looking for is positive. But we do need to be aware that negative result is there. It is a possibility because we have to account for the fact that a negative 5 squared is also a positive 25. And that square root is there to reverse or to inverse the power. Now, any of you that have your calculators with, I want you to try this. Some of your calculators will do this just fine, but many of your calculators are going to give you a problem here. If I do negative 2 and then I hit the x squared key, my calculator is saying negative 4. What should the answer be? 4. Negative 2 squared should be negative 2 times negative 2. Should be a positive 4. The reason being is my calculator uses order of operations. We'll talk about that in the next couple of classes. A power happens before a negative. So what this is doing here is it's actually squaring the 2 to get 4, and then it's applying the negative to it. So on my calculator, to make this work as a negative 2 squared, I actually do have to put the parentheses in, negative 2 in parentheses, and then hit the x squared. So in parentheses, negative 2, close the parentheses, and x squared. Now it will give me the correct answer of a positive 4. So when you're using negatives in your calculator, just be careful how you use them. Most of your calculators do use negatives. You have this key down here that's highlighted in red right now. It's a minus symbol with parentheses around it. That is the negative sign. You cannot use the subtraction key to put in a negative number. In some cases it'll work, in other cases it'll give you an error. If you have the 2-line display, that's the key you should have. If you have a 1-line display calculator, you most likely have a key that looks like this. That is the swap sign key. That key works slightly different. For example, on my calculator, if I want to enter in a negative 7, I press the negative key and then 7. That's negative 7. If you have a 1-line display calculator where you have this key for your negative, what you would actually have to do is you have to enter it backwards. You type in the 7, and then you press that swap sign key to turn it negative. So you have to enter the number first and then make it negative. If you're trying to use your calculator for these calculations and you have any questions or problems with it, let me know. I'd be happy to help you figure it out. For Tuesday, on your book, page 111, one through 39, the odds. Also page 114, 1 through 35, the odds. Page 116, 1 through 39, the odds. And there are word problems 51 through 79, the odds. Now make sure you do a few in each of these just so you have those operations down. I do also recommend, if you have your calculator yet, do some of them on the calculator so you get good, you know how to enter them in the calculator and make them all work. It's do some of the generic problems, but make sure you do a good sized handful of the problems in that 51 to 79. Those are the word problems. So I want to make sure you work on those and get good at those. Morning. We just put the homework up there for you.